So here I'm asked to find the lowest common multiple of both 40 and 56. Now, when I see the phrase lowest common multiple, I'm instantly thinking about using the prime factors of these numbers and how I can use these factors in order to find this lowest common multiple is kind of a skill that is taught and worked on at GCSE. I could simply list out a few multiples of both 40 and 56 and find the lowest one. However, this method makes sure that we've not missed any or done any of the calculations wrong, and we don't have to spend the time listing out these multiples. So if I take firstly the prime factors of each of the two numbers, so 40, I can split this into 2, which is prime, and 20, and again divisible by 2, and 10, and then 2 and 5 this time, and 5 is also prime. So those are my prime, that's the prime factorisation of 40. And I can do the same for 56. So again, I'll just start with 2 because it's easy to work with, and 56 divided by 2 is 28. Divide that by 2 again because it's even, gives me 14. And I can divide 14 by 2, and that will give me 7, and 7's also prime. So we have found the prime factors of 56 as well. Now to find the lowest common multiple of these, I'm going to put them into a Venn diagram. So if I take a Venn diagram and I have my two circles, and I'll label this one 40 and this one 56. Now I can put my prime factors in here. So as you can see, we've got 3 2's that are the prime factors of 40, and also 3 2's for 56. So these can go in the intersection of the Venn diagram, the points where they cross. I can put in the 3 2's. Similarly, I can now take the other factors, so 40 has a factor of 5 that hasn't been counted, however 56 does not, so that just goes in the region that's just the 40, and then similarly the 7 can go in here. So now to find the lowest common multiple from this, I can use these prime factors, taking into account the shared prime factors here, so the 3 2's, and multiply them all together to find the lowest common multiple. So we have 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 7. And this is going to give me the lowest common multiple because it's taken all of the prime factors into account but taken out any duplicates. So we've gotten rid of any of the prime factors that we've been sharing here. So this gives me an answer here, if we multiply these together, of 280. And we would have gotten the same answer if we'd have listed the multiples. However, it would have taken a little while to get to 280 when looking at multiples of 40 and 56. So we'd gain the first mark here for finding the prime factors of both numbers, or for listing at least 3 of the multiples, and then the second mark is for getting the correct final answer here. I'm now asked to write down the highest common factor of A and B, which we have above. Now this is similar to the previous part of the question, in the sense that I'm going to go with a kind of Venn diagram approach to this again. So looking for the highest common factor instead of the lowest common multiple this time, if I were to draw out a Venn diagram of A and B and their prime factorisation, the highest common factor is going to be whatever's in the intersection, so this region of the Venn diagram, multiplied together. And that's going to take the common prime factors, multiply them together to gain the highest common factor of both A and B. So in this sense, I could draw out the Venn diagram, or I could just look at which prime factors A and B have in common. So A has 2 to the power of 3, so that's basically the same as taking 2 multiplied by 2 multiplied by 2, multiplied by 3 multiplied by 5 is the prime factorisation of A. Similarly for B, we have 2 squared, so 2 multiplied by 2, that's multiplied by 3, multiplied by 5 squared, so 5 multiplied by 5. Now I just need to look between A and B and find these factors that are in common. So if we take 1, 2 from each one, and then we can also take another 2 from each one here. We can take the 3, that's common, and then we can take 1, 5. So there's lots of common factors here. However, we have this multiplied by 2 in A and the 5 in B, which aren't common, so we can just work with the ones that we've circled. So then the highest common factor is going to be 2 multiplied by 2 multiplied by 3 multiplied by 5. Here, multiplying the common factors together, and that gives us an answer of 60. And that is going to be the correct answer here to gain us the mark.